All right, we had a whole chapter, I don't know, a couple, 3 chapters ago, something like that, about congruent figures, right? Or congruent polygons. And we basically talked about triangles, didn't we, when we talked about congruent things? But you can have all kinds of things, okay? Okay, we started. Okay, so polygons is what we're going to talk about. So I just happen to have a polygon. Oops, right there. Not cool. I'll make it a little bit smaller. All right. So there's a nice little polygon right here. How many sides? 1, 2, 3, 4, 5, 6 sides. So it's a hexagon. It's not a regular hexagon. It's just plain old hexagon, right? Now, what if I did this? What if I copied? All right. I hit Control C for copy, and then Control V for paste. All right. So you know what I'm doing. What's true about these two things right here? If I just copy and paste, they are what? They're congruent, okay? So they're congruent. What does it mean to be congruent? All the corresponding sides have to be what? Equal to each other. And what else? All the corresponding angles. So if I took this, picked it up, and put it right on top of it, it would be the same exact thing, wouldn't it? Okay, that's congruent. You with me? All right. What if I did this? What if I just took a corner and just dragged it? I'm not touching anything else. I just dragged it like that.
Similar.
Okay. Is it similar? Actually, I still got that on top of each other. There we go. No, because look, none of these angles. Look, I didn't just change how long the sides were, but I also changed the what? Like this. I changed the size, but I also changed the
dimensions.
Let's use another word. I changed the size, and I also changed the, give me an S word, give me the shape of it, right, okay? What if, though, let's go back to what I had before. Okay, what if I had this? Oh, I know it. Okay. What if I took this, and I actually hit the Shift key? You ever do this? You ever work with, like, graphics and stuff like that on a, like, I don't know if you... I don't use Word very often because I use these other programs, but you could probably do this the same. If you work with a graphic, a picture, or something like that, you ever do any kind of project where you import pictures into your paper or your project and stuff like that, okay? And I'm going to show you a demonstration in a little bit about a picture. But watch, if you hit the Shift key, you grab one of the corners and you hit the Shift key and you drag it. Now look, I'm changing how big it is. See, look, I'm moving the mouse around like this, but it still keeps the same... Well, not the dimensions, because the sides definitely got bigger. Look at that side right here and this one right here. That definitely got bigger, didn't it? Okay, but what did I do? I changed the size, but it kept the same shape, didn't it?
Same angles.
That's right, exactly right. It has the same exact angles. In fact, watch, let me do this. Now, if I took this, like with the congruent, remember I put one on top of the other, and they were exactly the same. If I put this right on top of here, it doesn't fit exactly, does it? But let's do this. Let's take it and drag it so that, let's say this top, see that top angle up there? And I put it right there so it matches up. Look at the angle to the little one and look at the angle to the big one. Same exact angle, isn't it? Even though the bigger one is way bigger and the sides are bigger and stuff, that angle is still exactly the same. Let's go this one. Let's match up this one and this one. Okay, so I'm going to take this, drag it over about right there. Okay, it's pretty close. That angle's the same. I don't have to do it 6 times, do I? You get the idea. So this one down here would equal this one here would equal this one, and this one would be equal, and that one would be equal. Agree? All right. So what do? We changed. I tell you what. Somebody said the word. Who said it? It wasn't right before, but it's right now. Okay. So what we do is we call this similar polygons. Similar. So it's a little different than congruent. Congruent means all the sides are equal and all the angles are equal, right? The corresponding sides are equal and the corresponding angles are equal. On similar polygons, we have 2 things as well. We can say that the corresponding angles are equal, just like it was true on the congruent polygons, but something's different about the sides. Now watch. Let's say, I'm just making this up, okay? Let's say this is 2 and this is 6 right here. You with me on that? So how many times bigger is this big one than the smaller one? It's 3 times. So if I wanted to make up a ratio and compare the sides of the small one to the sides of the larger one, I could compare them small to large, right? I could go small, nope, let's do it like this. Small to, let's call it big instead of large, okay? From the small one to the big one, what is it? It's 2 to 6, and if I reduce it, it's 1 to 3. What does that mean? That means for every one you go on the small one, how many are you going to go on the bigger one? You're going to go 3. Some people would say, well, it's 3 times as big. Yeah, you could think of it that way, I guess. So if this was, let's say that one right there. Let's say that one was 5. This one's the one that corresponds to this one. What would this one be? This one would be 15. You agree with that? Okay. Yeah? But what's true about the angles? The corresponding angles are all equal, but what's true about the sides? Watch, 2 over 6 is the same as 5 over 15. Would you agree? If I have 2 ratios set equal to each other, what word did we use the last lesson when I had not angles, but 2 proportion, or I just gave it away. When I have 2 ratios equal to each other, 2 fractions equal to each other, I call that a proportion. Very good. You guys catch on quick. All right, so what can I say? I could say that the corresponding sides, they're obviously not equal to each other. Would you agree? Look, 2 and 6, they're not equal to each other, but the corresponding sides are what? In proportion. That means for every one you go here, you go 3 over here. So if this is 5, what do? You multiply it by 3 and you get 15. If this was 7, then this side over here would be what? 21. Make sense? Okay, so there we go. Now look at this 1 over 3. This 1 over 3 is important, and I'm going to give it a special name, and we call this the scale factor. Scale factor. Now this is a very, very important number. We're going to use it a lot. All right, so this is the first time I've shown this to you, but we're going to use it a whole bunch. Scale factor is 1 to 3. If I'm comparing the small one to the big one, what if I wanted to compare the big one to the smaller one? What would the scale factor be? The small one to the big one is 1 to 3. What would the big one to the small one be? Come on. It's not that hard. 3 to 1. That's right. It would be 3 to 1. Make sense? It all depends on which one you're comparing it to. All right, so if I say compare the small one to the big one, and the scale factor would be 1 to 3. If I compared the big one to the small one, then it would be 3 to 1. Agreed? Because what? 6 over 2 is 3 over 1. 21 over 7 is 3 to 1. 15 over 5 is 3 to 1. Make sense? Okay, so the scale factor is really a big deal and is very important. So what's true about similar polygons? It's these 2 things right here. These are really important. First of all, the corresponding sides are equal to each other. So I'm sorry, the angles, not sides. So let's say this angle was, I don't know, 130 degrees. Coming over here, this would be the corresponding angle. This one is the one that matches up with this. So what's this angle have to be? It has to be 130 degrees. You got it? Okay. And you could just keep going with the rest of them. You understand that so far? It's pretty easy, right? Okay. Let's do something else with it. Let's do an example. I'll pause this while I write down the picture for this. All right, here's a four-sided figure. All right, looks like a trapezoid, but we don't know it is. We just know it's some kind of a quadrilateral. Okay, and they call this, let's label it ACDF. All right, so they'll call this ACDF. Now watch what they're going to do. They're actually going to, I copied and pasted it, but watch, I'm going to make it a little bit smaller, like this. And it looks like they do a couple things to it. It looks like they flip it. So let's see, transform. It looks like they kind of flip it about the vertical, like that. See what I just did? It was like this, and then I went, boop, like that. Okay, see what I just did? I just flipped it around the other way. And then they flip it upside down. So let's see if I can do that. Reflects about the horizontal. That should flip it upside down. Yep. Alright, so there we go. And let's label this one. That's a Y, that's Z, W, and V. Alright, we good so far? Tell you what, let's make this just another color. Let's make it blue. There we go. All right. Here's what they tell you. Oh, there's a little symbol, by the way, for similar. It's kind of like, you know what the congruent symbol looks like? It was an equal sign with a little squiggly thing on top of it. Right, the similar is just a squiggly. All right, so I'll tell you what, we'll keep it the same color here. Oh, what did I just do? Let's make that yellow. Okay. It's just a squiggly. So they tell you this. This is the information they tell you. And then it's V, W, Y, Z. Now that's really important. A lot of people look at this and say, you know, okay, big deal. All they're doing is just renaming, you know, those figures. Let's put it over here. But it's really stuff that helps you out in a practical way. Because look at this. It goes A, C, D, F, and then what's the order over here? V, W, Y, Z. It's not like you have to look at it and say, okay, what did they do to it? Yeah, it looks like they flipped it. It looks like they twisted it. You know, you don't have to go through that. They give you the information up here, which really helps you out, knowing which angles equal each other and which sides are corresponding and all that kind of stuff. Because look, A and V, what must be true about angle A and angle V? They're congruent to each other. They're equal. So I'm going to mark them. Okay, so A and V are the same angles. Do you see it? What else? C and W. So C and W. Give both of those two arcs. What else? D and Y. I'll give this one 3, and then Y, I'll give that one 3. Because sometimes it's not so easy to see, you know, what they did to it. You know, did they twist it? Did they flip it? Did they do this kind of stuff? It's not so easy. So this is really important stuff to go by. All right. Let's put some numbers in here. That's 12. Why'd that go all yellow? Did I change that back? Tell you what, let's go back to blue. That looks better, doesn't it? Okay. Okay, that's all that. And now they say that this is 6 right here, and this is 10, and this is 3y minus 1. Alright, so it says these two figures are similar to each other. And let's just use another color to do my writing here. And we want to solve for x and y. So first thing I do is find that scale factor. I want to find two sides that correspond to each other. Okay, Matt, you getting all this? I want to find two sides that are corresponding to each other, and that I know the lengths of both of those sides. So, like, I know the length of this side. Let's see what this is equal to down here. Is the, not equal to, but which ones correspond? Does the 12 correspond to the 6? Well, they're both on the left-hand side. It looks like they would. But how do you know for sure if they correspond? Because you look at the side. What's this segment right here? It's A what? It's AF. So it's the first one and the last one. So AF is the same as what over here? VZ. So which one is VZ over here? This one right here. So it's the 12 and the 3y minus 1 go together. Do you see it? What other side do you know over here? You know the 9. So 9 is CD. It's the two middle ones. What's over here? WY. Where's WY? It's this one. So the 9 and the 6 are the corresponding sides. That's your scale factor right there. If I'm going to compare the big one to the small one, I'm going to compare it 9 to what? 6. Always reduce it. What does that reduce to? 3 to 2. So that's my scale factor. That's a really important number that I'm going to use throughout the rest of this problem. That's the scale factor. That means for every 3 I go over here, I only go what? 2 on this one. Make sense? Okay. So what are we going to try to do? Let's solve for x. And remember, the sides are in proportion. The ratio of my scale factor is equal to the ratio of the proportional sides. So what does that mean? It means this. Look at the x. Which one do you think matches up with the x down here? It kind of looks like the 10, but let's double check and make sure. FD, right, that's these last two, is the same as what? YZ, yep, or ZY. So yep, you're right. X and 10 do go together. So what I'm going to do is I'm going to compare, what do you want to compare? The big one to the small one? So I'm going to go what? X to 10 equals, what's my scale factor? 3 halves, 3 over 2. Everybody see that? Because remember, the sides are all, the ratio of the sides are all equal to each other. That means it's in proportion. So if I go x to 10, that has to be the same as 3 to 2, because every one of these sides is 3 to 2. This is 3 to 2, this is 3 to 2, this is 3 to 2. You get it? Okay. So x to 10 is 3 to 2. And then you just, now look, these are pretty basic and pretty simple to do. They're going to get a little harder though than this, okay? But this is the basic idea of what you're supposed to do. You could just multiply both sides by 10, but let's just cross multiply, okay? Let's get used to that. So it's 2x equals 30 divided by 2, x is 15. And that's one of the things I had to find. I had to find x, boom, got it. Done with that. Now let's solve for y. What do you want to use? Pumpkin squash. Okay. All right. So let's do the other one, the y. Let's see which one matches up with y. Well, we already talked about that earlier. The 12 does. So again, I'm going to go the big one, 12, to the small one, 3y minus 1 equals my scale factor. See, I use it twice, and that's 3 to 2. See, it's nice to have that scale factor right there. That's the first thing I always do for this, is to try to find that scale factor. Then I can take the sides that I'm trying to find, and I set those ratios equal to that scale factor. Make sense? All right, so let's cross multiply. So what's this? This is, let's do the math in our head. It's 9y, what? Minus 3 equals 24. Good. Add a 3, so 9y is 27. Divide by 9, y is 3. And there it is. That's your answer right there. You're done. Pretty simple, isn't it? All right, so what's the deal? Find the scale factor first. Okay, that's the very first thing I'm going to do, mathematically anyway, to this. Okay, is to find that scale factor. Then I'm going to take a look to see which variables I want to find. I want to find x, so I set up a ratio with x, and I set it equal to 3 over 2. I'm trying to find y, so I set up a ratio with y. Which one does y match up with? This one over here, this 12. Everybody understand why it matches up? Why they match up? Okay, why y matches up? And you just set that equal to 3 over 2. Boom, the math is easy. You're good to go. What do you think? Yeah, it's not too bad, is it? One thing I forgot to mention in the other class was this. Tell you what, just for fun, let's figure out what all these... Actually, we're not going to be able to figure out this one and this one because I don't know the lengths of either one of those. Oh, say one. Okay, say this is 5. All right, so if this is 5, what's this going to be? We'll call it z. So what do? You go z to 5 equals what? 3 to 2, right? And so no, it's not 15. What is it? 7.5, right? 15 over 2. So that would be, we'll make it a decimal, 7.5. Watch this. Who's what do we say x was? 15, right? And what's this side right here then? 3y minus, that's 9, that's 8. Yeah? So do we have all the sides now? Okay. Do this. Let's find the perimeter of the side. Somebody do that for me. 12, 15, 9, 7.5. I should be able to do it in my head, but I'll let you do it. Quick, who's doing it? What is it? Somebody else do it? Matt, you getting all this?
Yeah.
Good. Glad I'm giving you a chance to relax your eyes there a little bit. So what is it? 43.5? Is that what you said? Okay. Okay, good. You got it. And you did it in your head, too. Okay, do this one down here. That's 16, and that's 13, and that's what? 26? Is that right? Oh, what did I say? 16 and 23 is 29, right?
Yeah.
How about that? See, that's why I have you guys do it instead of me. Look what I did right there. I compared the top one to the bottom one. Somebody do that. Don't put it away. What are you doing? What's 40? I can't do this in my head. What's 43.5 divided by 29? Do it quick.
You should be able to
1.5.
1.5. What's 1.5 the same as a fraction?
1.5.
How about 3 halves? Check it out. Look. What did we say our scale factor was? 3 halves. Look what I did. I took all the sides, right, added them up. So basically the perimeter, here's the theorem. It's theorem 7.1. It's on page 467. Okay, and I'm not making you memorize these theorems. But if I took the perimeter of this and the perimeter of this, okay, and I could find out that the perimeters are in proportion with the scale factor. You see it?
Yes.
All right, and it should make sense too, because if all the sides reduce down to 3 over 2, well, if I added them all up, right, added up the one figure and added up the other figure and found the scale factor without, it would be the same exact thing. So it would be 3 to 2 as well. So that comes in handy sometimes, that the perimeter of this is the same scale factor as either one of these. You got it? Okay. All right. I think that's it. Well, you want some problems to do, don't you?
No.
Sure you do.
Yeah, I can finish it now.
Yeah, I finished this early. I was fighting to finish the other class. They had some questions on the homework. That's what took us so long, I think. All right. Let's see. Okay, here we go. It's section 7.2, pages 469, 470. Now, I break these up into 3 different little sections. So it's 8 to 15, it's 18 to 21, and then it's 23 to 26. Okay? So it's section 7.2. There it is, right there. Okay, write that down. And that's your homework for tonight. We'll go over it tomorrow. Have fun.